Okay, good evening, ladies and gentlemen. This is Professor David J. Delosreyes. My discussion for tonight will be a continuation of my long video format with this circuit, and this is lesson number 28. Lesson number 28, it's a derivation of the formula from y to delta. Oh, I just discussed the concept of y to delta or delta to y. Lesson number 27 was actually the derivation of the formula from delta to y. It was derived already. So for tonight, I will be deriving the formula on how to convert from y to delta. At least we know where those formulas are coming from. So I'll try to bring out for tonight. Okay, let's proceed. The subject matter for tonight will be the recurrent circuit, lesson number 28, and the title of the topic will be Derivation of y to delta transformation formula. It's a good thing that if we try to memorize a certain formula, at least we know where it came from. So I will now be bringing out the derived formulas for y to delta transformation. Okay, I will give you the final formula prior to the derivation. So formula number 1 will be something like this. R sub 3 will be the summation of RA, RB, RC, RA. If we are solving for R sub 3, where is R sub 3? R sub 3. The bottom portion should be R sub A. So this is R sub A. If we try to compute for R sub 1 on the delta equivalent, because the conversion is from y to delta, we are given the y's, we are solving for the delta equivalent. If we try to solve for R1 will be still same numerator, RB, RC, RA, and the denominator will be, if we are trying to solve for R1, the denominator should be RC. So this is R sub C. For the last equation, if we try to compute for R sub 2, okay, it will still be same numerator, right? But the denominator will be, if we try to compute for R sub 2, the denominator should be R sub B. So this is R sub B. So the transformation formulas, the final transformation formulas for y to delta will be this one here. Okay, same numerator, but the denominators are different. And for us to know the correct denominator, if we try to compute for R sub 1, the denominator should be R sub C. If we try to compute for R sub 2, the denominator should be R sub B. If we try to compute for R sub 3, the denominator should be R sub A. Okay, that's the final formulas, and we go to the derivation now. I will try to check my calendar. Okay, let's bring out the derivation. But prior to the so-called derivation of y to delta, let's try to bring out first the derived formulas from delta to y. It was lesson number 27. Okay, these are the derived formulas. It's different from this one because the first one here is delta to y, and what we are discussing for tonight is actually y to delta. So if I will try to bring out the derived formulas, lesson number 27, this is RA, RB, RC. Okay, the right hand side are with the subscript 1, 2, 3. So if we try to compute for R sub A, it will be the product R1, R2 all over the summation. If we try to compute for R sub B, it should be R1, R3 as a numerator all over the same denominator. If we try to compute for R sub C, because this is delta to y, right? R sub C, it will be the resistances adjacent to R sub C is actually R to R3. So this is R to R3 all over the solution. We needed these formulas and the derivation from y to delta. Okay? Because in here, instead of solving for RA, RB, and RC, what is given for the topic for tonight is actually Y to delta. What is given is Y to delta. What is given is RA, RB, and RC. And we have computed for RA, RB, and RC. And for this problem for tonight, this is what these are the given ones. So we must have to compute for R sub 1, R sub 2, and R sub 3. We will be reversing the equation. RA, RB, and RC, that's computed already for delta to Y. But supposing what is given is RA, RB, and RC, and the problem is asking for R1, R2, and R3. That is for Y to delta transformation. How could we solve for this one? So to bring out the equations for this, we start with this. Okay? We will be manipulating this equation such that we could compute for R1, R2, and R3. Okay, let's go to the derivation. From this given formula, lesson number 27, that is from delta to Y. If we try to take the product RA, RB, we try to take the product of RA, RB. Oh, just multiply it. This is RA. This is RB, right? It came from this. So if we now try to multiply this one, R1, R1, this will now be an R1 square. R2, as it is standalone R2. R sub 3 will be R sub 3. And the bottom portion, R1, R2, R3, R1, R2, R3, it's a double quantity. It's with the power 2. So the denominator now will be R1, R2 plus R3 plus quantity squared. This is quadratic already. We call that equation number 1. Oh, this is just algebra. Okay. Supposing we try to multiply the value RB plus RC emanating from this one. RB will be R1, R3, came from that. R sub C will be R2, R3, okay? And if we try to multiply this one, still the denominator will be R1 plus R2, R3 quantity squared. But the numerator, what will be squared will be R3 and R3 will be squared. R1 and R2 will be the same. So this is R1, R2, and what is squared is actually R sub 3 quantity squared. We call this equation number 2. Okay? Supposing we try to multiply the value RC times RA emanating from this one. RC is this one, R2, R3, all over this quantity here, or R1, R2 plus R3. And the value of R3 is actually, RA is actually R1, R2, the first one, all over R1 plus R2 plus R3. The operation is multiplication, it is within a quantity, right? So what will be doubled here is, It will be R2, right? R2 and R2, that will be R sub 2 squared. R sub 1 is a single one, it will just be simply R sub 1, and R sub 3 will be single one. Okay? We call this equation number 3. Okay? Next step. After taking these multiplications, we call this equation 1, 2, and 3. I mark this one as 1, 2, 3 because they are important equations in the simplification of the equation. Supposing we add equation number 1, 2, and 3. We add 1, 2, and 3. So for the left-hand side, okay, the first term on the left-hand side will be this one. It is 6. Next one, R sub B, R sub C. Next one, it should be R sub C, R sub A. That's for the left-hand side. And for the right-hand side, as you could notice it, the right-hand side, the denominator are actually the same for both equations number 1, 2, and 3. This is squared, squared, squared. So this is under one single denominator. For simplification, we lack space, right? It will just be simply the summation R1 plus R2 plus R3 quantity squared. Then we try to combine the numerators. The numerator on equation number 1 is this. It is this. The numerator of the second one is this one here. Right? And the numerator for the third one will be R1, R2 square, R3. This is the numerator. Under one single common denominator because these are all the same. Right? Then later on, we rewrite the left hand side as it is. For the right hand side, there is a common factor. The common factor is actually the product R1, R2, and R3. Okay? The first quantity is R1 because R1, R2, and R3 times R1 is actually the first one. And R1, R2, and R3 times R sub 2 is actually the second one. So actually we could bring out the common factor R1, R2, and R3. And R1, R2, and R3 times R sub 3 is actually the third one. Right? This is, the operation is multiplication, right? This is the common factor. We bring it out times the quantity, the sum R1 plus R2, R3. And for the denominator, it is actually quadratic, right? So we will rewrite the first one, then we will rewrite the second one, because the product of this one and this one is actually R1 plus R2 plus R3 quantity square. The operation here is multiplication. Okay? So it's a problem under algebra, right? If the operation on both the numerator and denominator are multiplication, we could try to cancel out similar factors. And this factor here is similar to this. Okay, so what will remain will just be simply RA, RB, RB, RC, RC, RA. And the resulting equation now, I mark this one as equation number 4 because it seems it is now much simpler. It seems this is gone and this is gone. Right? So it will not just be simply R1, R2, R3 all over the summation R2, R3. Of course, this is 1. This is 1 because it cancels out. Okay? And to compute for R sub 3, I prefer to solve first for R sub 3 before proceeding with R1 and R2. From this equation here, okay, RA from the original delta to y. Because all these equations emanates from this, right? So if we try to take another relation, we will be still getting from this. RA is actually the product R1, R2 all over the summation R1 plus R2 plus R3. And if we try to compute for the summation of R1, R2 plus R3, I put it on the left hand side. It will now be equal to the product R1, R2. Okay, I will divide this one by RA, so it will become RA. O equal this equation number 5. I'll try to check my camera. Right? So we're running through. Then substitute equation number 5 to number 4. Right? Because it seems equation number 4, we could not compute for R1, R2, and R3. The right hand side is complicated. But by taking the value RA equivalent to this, we could simplify the right hand side. So if we try to substitute equation number 5 to equation number 4, the left hand side will be as it is, right? And for the right hand side, we are calling this. It will be the product R1, R2, R3, and we will replace this one here by this value, right? We replace it. So instead of writing R1, R2 plus R3, we could make it simpler by just replacing that by R1, R2 all over RA. Okay? Actually, the numerator is actually R1, R2 over R3 all over 1. So numerator, denominator, numerator, denominator. We could cancel some factors on both the numerator and denominator. They are the same. So actually, R1, R2 cancels with this. Okay? And this RA here will go up. So the left hand side will still be RA-RB, RB-RC plus RC-RA. And this RA now, because if we would show that this RA here goes up, we multiply this by RA, and we multiply this by RA. So the resulting numerator now will just be simply RA times R3, and this RA here cancel with this. So the overall simplification of this is now just simply 1. So what remains on the right hand side will be just be simply the product RA, R3. And the resulting right hand side now, there is only one unknown now. It will be R3. So if we try to compute for R sub 3, we will multiply all the terms by the reciprocal of RA, of 1 over RA. So R3 RA times 1 over RA cancels. So the only unknown now will be R3. And for the numerator, it will be this ones here, RARB, RBRC, RCRA, all over RA. That's the formula on how to compute for R sub 3. This one. If we try to compute for this, according to that formula, the given resistances are actually the Y's, right? So it will be the product RARB, RBRC, RCRA, and the resulting, what do you call this, resulting opposite of this one on the Y is actually RA. So this is RA. Right? And it follows that by following this orientation here, if we try to compute for R sub 1 will still be same numerator, but the denominator will be different. If we try to compute for R sub 1, it will still be the product RARB, RBRC, RCRA, but the denominator should be R sub C. Right? So this is R sub C. And for R sub 2, I bring out this one by just following the orientation of this one. If we try to compute for R sub 2, it will still be the numerator will still be the same at the product RARB plus the sum of RBRC plus the sum or the product of RCRA, and the resulting denominator should be R sub B. So this is R sub B. So under the transformation from Y to delta, okay, the resistances with the subscript ABC are actually the given Y, right? These are all given. These are all Y resistances. And we are computing for the resistances with the subscript 1, 2, 3. So this is R1, R2, R3. That's the delta equivalent. The delta equivalent are actually R1, R2, and R3. And the given Y is actually RA, RB, and RC. So if you try to notice it, the formula on the right hand side, these are all the values that is given on the Y formation. Okay, that's it, guys. That's the so-called derivation of the formula, a transformation from Y to delta, and that was the derivation. So just in case you try to convert from Y to delta, we will be using these formulas here. That's it, guys. So for those of you who would like to subscribe or watch my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to click it, please click share. For those of you who do not know yet that my channel contains long video format discussions, I am emphasizing tonight, but my long video format discussions, it's done already. It's a complete syllabus. I am done with differential calculus, integral calculus, differential equation, advanced math, DC circuit, AC circuit, algebra, and trigonometry. Those are long video format topics. So if you try, what you call this, if you plan on taking up engineering, it will be a wise thing if you would like to watch my channel. Okay? Good evening from Los Angeles. This is Professor David J. Delosreyes.